Gupta ji to Osmania University Engineering College, in particular Department of Electronics and Communication Engineering Department, as well as our workshop, which is scheduled from day before yesterday. I would like to invite Satya Gupta ji onto the dais. Sir has completed his BE from BITS, Pilani, ME from MTech from IIT, Delhi. So he received his Distinguished Alumni Award from BITS recently. Congratulations, sir. There is one thing called VLSI chapter, VSI we call. So he is President of VSI of India. So we are also looking for more collaboration from in terms of VSI. That's what I was discussing with him.
Thank
coming
you
over
very,
and
thank
talking.
you very much.
So thank you.
Two part of my discussion today. One is about what's happening in semiconductor domain, India, worldwide, and second is little bit technical, which basically we will go through. So, if you look at this picture, in 1980, when India was building its first basically rocket, the rocket nozzle was carried on a bicycle because no vehicle could go there, right? From there we have come in basically about 40 years where we could send a rocket and launch a basically rover on the south pole of the moon. So, phenomenal progress basically made in different aspects of the technology, which this basically picture is kind of depicting, right? And now, currently if you look, basically India is on a continuous move upwards, right? And the foundation of basically this upward movement has been laid in programs like Startup India, Digital India, Make in India, India Semiconductor Mission, and many such basically foundational programs which are paving the foundation for further development. And the result of these basically foundational program is that we have been able to create something which we generally refer to as digital public infrastructure, which can basically affect every citizen of India at a population scale. And some of the examples of this is Aadhaar. How many of you have Aadhaar card? All of you, right? How many times a day you use UPI? Probably 5, 10? Okay. ONDC is a platform for small merchants to basically get onto the e-commerce bandwagon because they cannot build the platform like Amazon or Flipkart. So, Government of India made this platform where a small merchant can basically also participate into e-commerce, right? Vande Bharat Express, totally modernization of the train. Yesterday I went, yesterday morning I went. The average speed was about basically 100, peak speed was about 130, right? And totally smooth at that speed also. So, that is the kind of the revolution which is happening. And programs like Bhashini, which is a platform, AI based platform to convert any Indian language to another Indian language, either text to text, voice to voice, voice to text, text to voice, right? It's available on the Play Store if anyone wants to use it. I think it's a pretty accurate, right? When I used it first time, we were inaugurating one of the platform which we created called Epic Foundation. So, I asked it to translate it, welcome to inauguration of Epic Foundation. And I asked it to translate it to Hindi. Can somebody tell what it would have translated? Welcome to inauguration of Epic Foundation. Any Hindi gurus here? Okay. So, normally you will think that it will translate is ki Epic Foundation ke udghatan pe aapka swagat hai. Okay. What it did, right? It said महाकाव्य के उद्घाटन पे आपका स्वागत है, because epic translation is basically महाकाव्य, right? So, it was very beautiful moment that basically it did such a perfect translation. So, now because of all of these things, right, what is the impact of this thing? We are fifth largest economy today, going to become basically third largest economy maybe in another 12 months. We are number one in the digital payments in the world, thanks to all of you. We are number one in the data consume, bigger thanks to all of you, because all of you keep watching, binge watching and all of those stuff every minute on the social media, right? Mobile production, we are number 2. Startup, we are number 2. Railway, number 3. Road, number 2. And when we talk about Viksit Bharat, right, we hope that by 2047, when we reach to 100 years of independence, then all of this will become number 1. That's the aspiration. Now, coming to more about subject which we all basically are involved with, electronics and semiconductor. Electronics and semiconductor today has become very strategic for any country, for economic development, strategic development, geopolitics, from all the angles, right? You hear so many things, maybe how many people saw a news about new tariff which US has put on the China today morning? Did anybody see that news? Okay. So it's become a weapon of basically geopolitical thing also. It has become very, very important for economic development. So if you look today, India in 2023, means data is little low, we consumed about $200 billion of electronic goods, right? Be it mobile phone, laptops, all put together, $200 billion of electronics good with Indian consumer bought, right? Which had about $40 billion of semiconductor in that, right? So, pretty huge number. But if you look at 2030, when we basically reach end of this decade, right, the electronics consumption will reach $500 billion, and proportionally the semiconductor content in those will be about $135 billion, right? But when we move to 2047, these numbers go to a staggering proportion, right, which is $3 trillion of basically electronics consumption in the country, and $110 billion of semiconductor in those products, right. If you look today, the global market for the semiconductor is about $600 billion, right. From that point of view, India alone will consume $800+ billion of semiconductors by 2047, right. And in terms of the country impact, today basically we have this electronics represent 5.8% of the GDP. By 2047, it will become 10.2% of the GDP. That means it is growing much faster than other areas of economics. That's why it has become the bigger percentage of the GDP, right? And it has a potential of huge number of job creation also. If you put direct and indirect job, which we have potential of creating by 2047 is 10 crore, which will be about 8% of the working population, right? So again, pretty big numbers, right? Now, so this is the opportunity. Where we are today, we consume about 200 billion of electronics, which will become 500 billion, let's say by 2030. If you look at the Indian products, out of the $200 billion of electronics we consume. So that tells us basically that although we are consuming large amount of electronics, most of it is foreign products, foreign brands, right? And mobile phone is just an example of that, right? So if you look overall, less than 10% of the products which we consume basically are Indian products. Now, if we do things right in next 7 years or so, and we say that we will move this 10% to 33%, right, which is very justifiable for a country like India with so much technical brain power and everything, right, then it creates an opportunity, business opportunity of $166 billion, right. They are big, big numbers, so just take it. In semiconductor, if you look, $40 billion we are consuming as part of this product, which will become $135 billion. Indian chips are less than 1% of what we consume. Okay. When I say Indian chips, made by Indian company, right, designed by Indian company, not necessarily manufactured in India, but just at least product ownership, just like Qualcomm, Broadcom, they don't manufacture any of their chip, but the product belongs to them, right. From that point, if you look, it's less than 1%, right. And again, if we aim for 33%, then it creates a $45 billion opportunity. 2047, and by that time, if we say that 50% will consume the global products, but 50% of what we consume will be Indian products, right? That creates an opportunity of $155 trillion, which is basically almost half of the total Indian economy today, right? Today we are about 3.6 or something like that, right? So that's the opportunity sitting in front of us, which represents almost a 75x growth for basically this particular sector. And just to give a historical perspective on the cell phone, right? In 2015, the Indian brands or Indian products held basically about 15% of the market, right? In 8 or 9 years, that market has gone from 15% to less than 1%, right? And Chinese brands, which were couple of percent in 2015, like 2-3%, right? We did not have any Oppo, Vivo, Xiaomi, MI. 2015, none of them were there, right? So they were less than 1%. Now they have become 75%, right? 75% of the phones which get sold are some brand or other of the Chinese phones, right? Hopefully by 2030, we can grow the Indian brands to 20%, and basically by 2047, basically we can grow the Indian brands to 50%. That's what we are aiming for. So now, if we have to bring this transformation, we have to work on basically different aspect of the basically industry ecosystem. Typically, any industry can be defined by the products it creates, right? Be it steel, be it automobile, anything, right? So products are the driver. On one side, we have electronics products, which are finished product like this camera, or mobile phone, or laptop. Other side is the chips which go and drive these products, right? So we need to build the products on both the sides, right? Irrespective of where they get manufactured, we need to become a product basically nation. Now, if we want to make them, then we have to create a manufacturing ecosystem also. After designing the product, we have to find a way to manufacture them. So we have to create a manufacturing ecosystem. And how we are going to design these products if we don't have the people to design these products. So we need to develop talent both at the engineering level and the research level and basically R&D, so that basically these products, we have the capability to do these products, capability to do the advanced manufacturing and all of those things. For that, we need basically talent development, skilling, infrastructure, all of these different elements we need to build an ecosystem with, and we need government policies, which are long-term policies, not that every 5 years we keep changing the policy. Long-term sustainable policies like what the different nations which are advanced in these areas have done, like Taiwan, Israel, Korea, Japan, US. They have long-term policies and they are basically getting the benefit of this. So we need to focus on the products. For manufacturing the product, we have to create the ecosystem for manufacturing, and for designing the product, we need the research and talent ecosystem. So now when we talk about the semiconductor, we talk about the NVIDIA today, but the point I want to emphasize is the product companies are the largest companies today. If you look at the 3 top companies in the world today across all the sectors, they are electronics and semiconductor product companies, right? We talked about NVIDIA, second is Apple, and third is basically Microsoft, right? So these 3 are the largest companies today. We may see Microsoft only as a Windows and basically Office applications, but they are very large makers of the semiconductor device also for their game game console like Xbox and basically their data center. So these are the three largest companies. All of them are product companies. All of them basically make their own products and basically incidentally, they all basically are semiconductor companies also, fabless semiconductor company. They are not manufacturing company. They design semiconductor products and then get it manufactured. Now, we are seeing the growth of India from basically 200 billion to 3 trillion, right? But globally, if we look, what are the trends which are basically propelling the growth of electronics and semiconductor industry? So I noted down 7 main areas. So AI ML is the basically big daddy right now. In 80s and 90s, we used to, when I was at Intel, we used to say what will be the killer app for the microprocessor, right? And somebody said Windows, somebody said PC, this thing. So today, obviously, the killer app is of this decade is AI ML, right? And other sectors which are growing basically overall ecosystem is automobiles, electrical vehicles, consumer electronics, telecom, wireless systems, medical, biotech, energy and clean tech, and space and defense. So combine these areas, they are all basically going through the explosive growth and thus making the electronics and the semiconductor very large basically field both for India and both for the world, right? And as we are looking that basically AI ML is getting into everything, right? Even if it's auto, there is some component of it AI ML goes. Consumer electronics, some component of AI ML goes, right? So now when we talk about AI ML, why did it become basically suddenly in last 7 years so omnipresent and basically so impactful, right? The AI ML and the foundational algorithm for AI ML existed almost for 4 decades, right? When I was doing my PhD in 1988, 89, right? We studied basically almost the same thing, same type of the neural network, same type of the multi-layer and those things. But it did not create that kind of the impact at that time, right? Now, suddenly, basically in last 7 years, why did it create impact, right? So I think there is a very symbiotic relationship with AI, ML and semiconductors, right? When I was doing PhD, I spent 1 year working on the neural network, right? For simulating 500 node neural networks with couple of thousand parameters, right? We needed a small supercomputer to do that today. Today, if we see, right, OpenAI or Meta, LLM and all of those things, right? They are simulating the neural network with billions of parameters, right? When you have the compute and memory power to basically simulate the neural network or transformer or whatever algorithm you are using, then you can solve the realistic problem. Think if you were already have 500 parameter neural networks, you will be solving only toy problem and the classroom problems, right? So semiconductor compute power and semiconductor storage made AI possible whatever it is today. So if there was no chips which can run such a large model, if there is no memory basically which can store such large model, then AI will be still good theoretical subject, but its impact will be limited. So while AI ML is progressing with algorithm and application, semiconductor is basically progressing with compute and storage, and in some sense basically the two are driving each other. Once we have more powerful chips and more storage, we can basically create better AI models, better algorithm. And when we have more powerful AI models, they in turn can help in basically designing more powerful chips, right? So it's kind of basically a very symbiotic relationship. One is feeding on each other because AI can help solving some of the chip design problems, which basically will make the chip design process much easier, much more efficient. Once we have more efficient chips, we can do more AI, right? I think it just basically goes together. So when we talk about the chip design, as most of you are already into it or probably going to go through it as you call. So, security has become one of the biggest application area. Every chip which comes out, they think about the security, how it can be made secure to the cyber attacks and everything. Custom chips is another trend. 20 years back, only few big companies, Intel, AMD, Qualcomm, Broadcom used to make chips, right? And these were generic chips, right? Today, the customers are doing their own chips. For example, Apple is doing their own chip, right? Mercedes wants to do their own chip. So, they want to do a custom chip of their own because they want differentiation, cost, all of those things. So, there is a big trend of doing the custom chips for large enough application. Every data center company, be it Azure, be it AWS, they want to have their own chip, so that basically they can build their data center to their own choice, right? Third thing is architecture explosion. Couple of decades back, we had basically single architecture, fetch the instruction, decode, execute, dispose, right? Everybody was doing the same thing. But with the explosion of AI, so many new type of the architectures are coming, which is basically making the whole chip design field very interesting. There are things like systolic architecture, neuromorphic architectures, and so on and so forth, which don't follow the traditional model of basically fetch, decode, execute, dispose type of the model. They work on a basically very different model, which are suitable for AI type of the applications, right? Chiplets and advanced packaging. How many people have heard about chiplets? Couple of them, right? So, basically, when we are advancing on the technology nodes, we are now at about 2 nanometer, probably will get to 1 nanometer by next year. I think we are hitting a limit where every generation of the miniaturization is not giving as much benefit, right? One is cost is very prohibitive, second is the benefit in terms of the performance power is not as much as it used to be earlier when we move from generation to generation. So, we have to devise newer ways to basically keep advancing the performance or memory and other things per chip, right. So, that is where the chiplets came, where you can take basically multiple chips, put them in some kind of basically 2D, 2.5, 3D, 4, 3D kind of the shape and create more powerful chips, so that you can basically continue to do what we used to call Moore's law. I don't know how much valid it is today, but continue to progress at that space, right, because once you do vertical integration of the chips in the same horizontal area, you can pack more power, right. Wireless is becoming very important. We already see that in so many ways we are already using wireless, but the way things are going, in another 10 years, any chip which get designed for any purpose, will have a wireless capability, whether it's a Bluetooth or Wi-Fi or Zigbee or cellular or any of those basically wireless protocol, but every chip will have a wireless capability, because that's how the use cases are going, right. Photonics based interconnect, very high performance chips, basically the interconnect between the two chips are basically consuming a lot of power and bandwidth issues. So, there will be basically some type of the photonics or light based interconnect between the chips which will come. And heterogeneous and vertical integration of various technology. Today, we are not doing like on a wafer, either we do logic or we do memory, right. On a wafer, when we build semiconductor chips, either we build the logic chips or the memory chips, right. In the future, maybe on the same wafer as a vertical layer, we will have one layer of compute and then memory and then compute and then memory. So, it's little bit futuristic, but this is the direction where the industry is moving to, right. So, these are the 7 key trends in the technology for chip design. Now, what is India doing about all of these things, right. So, in beginning of 2022, India announced the India Semiconductor Mission with the goal of establishing semiconductor design and manufacturing both in the country. So they announced an incentive package of $10 billion, about 76,000 crore. This is a picture from the first Semicon which happened in Bangalore in 2022 after the policy announcement. What basically this policy did is that Government of India for any manufacturing basically project, whether it's a wafer manufacturing, packaging or memory manufacturing or even display manufacturing, they will give 50% of the project cost. So if your project is basically costing $5 billion to set up a fab, then government will give 50%, like $2.5 billion of it. On top of that, some of the state also came forward and they said, we will give additional 20 to 25%, right? So in all it became 70 to 75% of the project cost, right? If a $10 billion project comes, then 75% government pays, 25% industry pays. In my limited basically knowledge and experience, no country in the world is giving these kind of basically incentives, not even close. The US have announced CHIPS Act, which is about 25–30%, but that's not real money. Sometimes it is a soft loan and you have to pay back and all those things. In case of India, it is given. Grant one time, no payback, no equity, no nothing, it's just grant. So I think this is the best incentive package any country today have in terms of the subsidies for setting up the semiconductor manufacturing, right? It applies to, as I said, all type of nodes, and so many companies have basically come up and basically announced their plans to set up the fab. First was Micron, they plan to do the memory packaging in India. Then Tata announced 2 plants, one is for wafer fabrication, then CG Power for OSAT, which is packaging and testing. Tata also announced another project for packaging and testing. Keynes announced one more project for same thing. Tower and Adani wants to set up analog fab, and RIR is setting up a silicon carbide fab, right, in India. So, and I think in next 6 months, at least 3 to 4 projects may get announced. So that's the impact of basically this policy, because before that, India tried once or twice every 7–8 years, we tried to announce for some policy for semiconductor manufacturing, but for various reasons it did not succeed, but this time we can see definitive success in this area. On the design side, product design side, so this is manufacturing incentive. Again, government basically decided that they will build an ecosystem of 100 semiconductor product companies, which we also generally refer as a fabless companies. For them, basically 50% of total expense of the chip design will be paid by the government. Free EDA tools, right? You may be getting the free EDA tools from the government as an educational institute. I don't know. If you are not, you should, because that is the another part I'm going to talk about. But for commercial companies, it costs about 15% of their project cost goes into EDA tools. So that is also given for free. So 50 plus 15%, 65% plus support on the IPs and all of those things. So all in all, again, we are talking about 70–75% incentive coming from the government. And again, some of the state government are giving 20% on top of it, right? So if you want to do a fabless chip startup, this is the golden time where government is almost paying 80–85% of the cost, and you have to basically bring in only 15% of the basically money from the investors and other people. And we are the 24 companies which have benefited from this program so far. Now, we talked about basically manufacturing, we talked about the product design, right? If any domain or any basically economy vertical has to succeed, there has to be a balance, right? We need to create a balance between manufacturing and products, right? If we don't create basically balance between the two, we will have manufacturing facilities but no products to build upon. We may build the products, but we don't have manufacturing facilities. So we need to create a right balance basically between the two. And what I generally refer is a 80–20 rule. that if you have a 100 rupees to spend as an incentive, put 80 in manufacturing because that's a more cost heavy basically activity, and 20% on the product design side, right? So like when ISM, India Semiconductor Mission, announced 10 billion of incentive, it was very much heavily tilted towards the manufacturing. Only about 100 million was given for the product design, and basically $9.9 billion were given for the manufacturing. If we really want India to become a strong semiconductor nation, then we have to create a balanced strategy that if you have $10 billion to give as an incentive, give $2 billion to product design and $8 billion to manufacturing. Until unless we create that balanced strategy, we will be going basically this way or that way, but will not create a strong ecosystem. So this is something which we need to still do. We are not done yet. We are not invested in the products as much as we should. But looking at the previous slide where the opportunity is so big in the products, it is imperative and I think a must for the country to spend in the product incentive as much as we are spending on the manufacturing incentive. So in other words, for every $10 billion, $8 billion on manufacturing and $2 billion on the product design, right? If we don't do this, then we can have fabs, but no Indian products being built in there. We'll keep building the foreign products and so on and so forth. So we need to, I'm not saying we should not build the foreign products, but if we don't build Indian products, then how do we progress the country? Few examples of what we can do in terms of electronics products and electronics chips out of India, because we saw that we have less than 10% of electronics products coming out of India and less than 1% of the chips coming out of India. What are the opportunities which we can just basically look at as examples? So we have the opportunity, we have to convert it into a business, okay? So we need to leverage unique Indian applications and also public procurement. Public procurement can be a big basically way of basically doing this chip. Some examples, right? Government of India is probably going to issue about 200 million plus basically passport, e-passport, right? Why can't we build a complete passport or passport chip out of India? This is our domestic application involves security, it requires, and believe me, creating a passport chip is not basically rocket science. It's a 65 nanometer, very simple chip. We have to just put our minds, look at the security and some other aspects, and we can create a passport chip very easily out of India. But we have to have a right basically coordination between different bodies, MEA, External Affairs, MIT, MHA, all of them have to work together, say, next generation passport chip will do from India, whatever it may take. If it gets, passport rollout get delayed by 1 year, what's the big deal? We have delayed it for 10 years, 1 more year we can tolerate, but let's have an Indian chip and Indian product, right? How many of you use DigiYatra? Why does kiosk has to come from Canada? The screen which you save, which does your face recognition, right? It's a tablet with basically a camera and some basically simple AI, right? Why can't it be built in India? When we were thinking about DigiYatra 4 years back, that time we should have planned that basically we will get it built by Indian company. There are hundreds of companies which can do that product. It's not very tough. It's a tablet plus a camera plus basically simple face recognition software, which is available abundant, right? But we could have built that product ourselves, right? When UPI came, there was no voice box, right? There was nothing basically which will tell you that this much payment is received, right? But it was expected it will come. Now, millions of these boxes we are importing from China. For what? It's a 400 rupees simple product, right? Which has a small microcontroller, a speaker, and internet connectivity SIM, right? That's all it is. Why could not have we built basically this product ourselves? So these are opportunities which basically if we planned correctly, then basically we could have built ourselves and create a market. There's so many security applications at the personal security, city, border, cyber security, and identity we talked. All of these applications out there. And they are basically, typically procurement is done by the government. So they can decide where to procure from, right? And build an Indian ecosystem around that, right? Automation application. This is another area, big area, which I'm generally saying as a powertronics, right? whether two-wheeler or four-wheeler EV, lot of power electronics will go in there, right? In terms of the motor control, charger, battery management system, and so many other things, right? This is our market, our OEM. We can build those products. We can basically develop compound semiconductor technology in terms of the GaN and basically silicon carbide and build this product ourselves, which will be almost 50% of the EV. Because motor controller, inverter is the one of the biggest thing. Then you have chargers, you have battery management system, voltage converters, all of that can be built, right? And not just that, if you look at all this power application, mobile charger, UPS inverter, white goods like basically air conditioned, microwave, fridge, industrial, four-wheeler, renewable, railways, data center, all of them basically require a power converter somewhere or other, right? Where AC comes and you have to convert it to DC. All of that can be served by Indian products by using the compound semiconductor technology like GaN and silicon carbide. So these are opportunities sitting in outdoors. How do we basically make sure that we take the maximum benefit out of our own basically demand? Drone is another basically application, whether it's basically drone for security, drone for agriculture, drone for logistics, drone for entertainment, right? It's a huge opportunity, $2 billion market, right? It's sitting in front of us. How can we create more indigenous drone companies where not just the final product, but the sub-components also like chips and basically subsystem in terms of the flight controller and everything basically gets built in India. Now we are building the drones in India, but still a lot of sub-components are imported, right? So again, huge opportunity, right? Trains, we have not invested basically much of our high-tech bandwidth from the trains. Till Vande Bharat came, which has done somewhat it, but still there are a lot we can do with basically using latest electronics and semiconductor and sensors and so on and so forth. Be it Kavach for safety, security, be it user convenience. Why Vande Bharat does not have basically a screen on the every seat, just like a plane, right? Not very expensive proportion. Why it does not have Wi-Fi? We can provide all of that and provide the better basically services through that and also create market through those applications, right? So enough about Indian products. Now coming to the subject where we are basically here. As we said, three pillars of any industry: products, manufacturing and talent, right? Academia is obviously responsible for developing the talent as well as basically providing some foundational R&D for new areas of products and so on and so forth, right? Where does the role of academia begins, right? When basically, let's say higher education, when a person graduates from +2 and goes to college, that's where basically he begins his journey of higher education. So it starts with a quality education first, right? If he gets quality education, then some of basically the people, let's say 100 people go through the BTech program where they'll get quality education. Maybe 20% of them will graduate to MTech and they will start doing some research and so on and so forth, right? Some of them basically develop very good technologies and some of them basically, some of those technologies will get converted into products. So let's say 20% at every stage we get, right? So, but the main thing is the journey begins basically with the quality education, right? If we don't provide a quality education, we will not have quality researchers, we will not have quality technology, we will not have quality products, right? So I think when we talk about everything in the academia, the first thing, why does academia exist is because of the quality education, right? That's the primary purpose of me, you, everybody sitting here, right? I think let's put extreme focus on providing quality education so nobody in the world can say that Indian engineers are unemployable, right? I think we need to remove that tag and that tag can be removed if we put 80% of our focus on the quality education. Research can come afterwards, but quality education is the first thing to come if we want to make our youth empowered with the right skills to become basically best engineers in the world, right? Not everybody is meant for research, right? So academia has to basically, I think, look inwards, outwards, both and see, are we putting enough effort on the education or we are basically putting too much effort on the research. Left side is academia driven. As we move to the right, it becomes more industry driven where industry can guide the product and the research and so on and so forth, right? So just like we need a balanced strategy between manufacturing and product, in education also we need a balanced strategy between teaching and research. And I am saying with utmost sincerity that because of various reasons, the balance has been tilted on one side. I will not say which side. This is fortunate. All our ranking systems, right? This is not for students, for the teachers, right? All basically talk about only research. There is no weightage of teaching. There is no weightage of teaching. So why will a professor teach? He will rather produce 10 papers than basically doing a good job of teaching, right? We need to fix it if we want to basically create a very good, and I am not saying neglect research, we need to create a balance just like manufacturing and products, right? At the BTech level, we need to basically focus our teacher and all the resource energy in teaching first. Then the research will come out of it, right? Not the research will produce the teaching, teaching will produce the research. So quality teaching will lead to quality research automatically. Any questions? We'll take a pause here. Any questions or anything before we go into little bit of chip design?
Sir, we see many smartphones, foreign brand smartphones like Poco, Samsung and all, and on the boxes they have this logo of made in India. Technically they are not Indian products because I guess at the most they'll be importing the components, they'll be assembling them in India, probably testing and then further packaging it. That's all that's being done. So isn't that quite misleading for the layman at least, who doesn't know where the company is actually...
It should have been manufactured in India, not made in India.
Right, right.
Okay.
So
it's really not made in India, whether it's take Apple or Samsung or anything, right? They are assembled and tested in India, right?
Right. So at which point do you begin considering a product Indian? Is it as simple as where the company is incorporated, like if it's incorporated
No,
in
it's not
India?
company is incorporated. There are three things, right? One is company incorporation should be India.
Right.
Okay. Revenue and financial benefits should accrue in India, and the IP should belong in India. These are three things which basically will define a company to be Indian or a product to be Indian.
Thank you.
It can be manufactured. See, on the reverse, you can develop a product manufactured in China, still it's an Indian product, right? Like if you look at Qualcomm, for example, right, or NVIDIA. NVIDIA GPU is a US product, right? But where does it get manufactured? Taiwan.
Taiwan, yeah.
Right?
Yes,
But product ownership remains with the company which owns the brand, IP and financial benefits of that basically product, right? That's how we define that product belongs to which geography.
This is Dr. Ram from AI Tech Park, Penang, Malaysia. Is the game for starting the semiconductor industry is only for the big players? How a startup owner like me to venturing with collaborative with many collaborative partners to pull the 30%? Everybody like Adani Group and Tata, is it the game for the big players? Where, how we can be part of the manufacturing of
opportunity in terms of the product design, right? If you look at the semiconductor industry also, manufacturing is only about 30%, 70% is the product design company,
yes,
right? So Qualcomm, Broadcom, NVIDIA, AMD, Intel, XYZ, right? All of them are product company. So there is a huge opportunity for entrepreneurs or basically students or people like you to design the products, right? Now, semiconductor products you can kind of break up into 2 or 3 categories. One is very high-end products like basically NVIDIA GPU or basically very large server CPU and so on and so forth, which takes 500 million or 101 billion type of the number to develop it. But there are a lot of microcontroller like a chip which goes into AC, right? It's not very complex chip, right? Which chip goes into this, right? Chip goes into your mic.
yes.
All of these are basically opportunities which don't require huge investment, right? Couple of $1 million, maybe $3 to $10 million, you can develop all these products, right? Okay. And they can be manufactured wherever it is, right? That's how the industry developed. Not that at very beginning, manufacturing and product design with the same company, what we call IDM. Then around 80s, we segregated it. Manufacturing companies became different, product companies different. That's where the fabless model emerged, right? So fabless companies emerged from 80 onwards, and now basically fabless companies are the biggest basically semiconductor companies today.
Is there an organization give us some consulting people like who want to venture into fab and end-to-end manufacturing?
See,
facility?
again I'm saying is the fab is basically very expensive affair and they are only plants.
If money is not the criteria.
Let's not get very basically fascinated with fab alone, right?
Yes.
Industry run on the products, not on manufacturing, right?
Yes, sir.
Okay. So yes, fabs are needed, but Fabs can be only few and very expensive, right? So if I am an entrepreneur, if I take myself, मेरी औकात में भी 10 million की है, right? मेरी औकात 10 billion की नहीं है, right? So I cannot think about putting a fab. So it's not for everybody, right? People who have that kind of basically sustaining power and the money, right? It's not about one-time money also. No fab in the world was built by an entrepreneur.
Sir, I am Mandeep Reddy from Srinidhi, Gatke sir. I have a question that can you give a brief basic idea on how to start a product-based company in India?
Just come up with an idea, rest we will do for you.
Like the
I
steps.
told you, government is giving 85%, okay. You have to come up with an idea, build a team of 3-4 people and start coding. You know Verilog? You know?
No sir, not.
You are going to learn soon,
Yes sir.
right? Just basically Verilog is just like Python, right? That was second part of my presentation, but I think we ran out of time. But see, hardware design or chip design is not tough. It's just like writing a software program, okay? So take that approach, come up with the idea that what chip you want to build, what will be the application, who is the customer, how much they will sell, and once you freeze the idea, rest all is very easy. So main thing is come up with an idea which is have a commercial viability, right? So once you figure out a product which is commercially viable, I think there are enough people in the industry and the ecosystem which can help you to build that product, right?
Sir, I want to ask that as an individual, if I designed a chip from scratch using some standard companies, products like Synopsys or Cadence, like front end, back end, I designed everything, and I have it ready in a software, then tape out. But if I want to design, like I want the original chip fabricated as an individual, how am I supposed to do that?
You come up with a chip, we will help you in taping it out.
No, sir, I want the fabrication done. Where am I
Yeah, that's
supposed
what
to
I'm saying.
approach?
Taping out means fabrication. Once you have done basically design your chip, come to us. Any of us basically can help you in fabricating the chip, depending on what technology you develop. See, when we design the chip, we design it for a particular technology, particular fab, right?
Yes.
You might design your chip for, let's say, 65 nanometer. Once you design the chip, if it is basically good enough project, right, we will help you in fabricating it, right?
Thank you.
There are enough organizations which will help. I will help personally you to fabricate the chip.
Thank you, sir.
But your idea has to be good, chip has to be good, right? Not bache wala, not toy chip, it has to be really meaningful chip. Then we will help you in fabricating the chip, right?
Thank you, sir.
Sir, one last question.
We'll give the financial assistance, whatever you need.
What are the possibilities that students can enter into, become an entrepreneur in semiconductor industry? What are the possible ways that student can become an entrepreneur?
See, what I told him is the same answer. You have to come up with an idea that what chip you want to build, right? Once you decide what chip you want to build, assemble a good team of 3-4 people.
I mean that in the industry there are some standard softwares they are using where they are not free softwares, they are paid. So
Government is giving, I told you that, right?
Sir, okay.
Osmania University has this files. Any startup, government is giving those software for free. That's why I'm saying you come up with an idea, build a team which basically knows the technology and business both, okay? Take a
Thank you,
person from MBA, take 3 people from engineering, build a team. We will help come up with idea. Your job is to mainly come up with an innovative idea. Rest, we will do it for you. Thank you.